It gives me great pleasure to present our first guest speaker, the Honorable Nelson M. Ford, Undersecretary of the Army. Mr. Ford will be speaking to us by VTC from the Pentagon. At least I hope he is. Mr. Ford has served as the Assistant Secretary of the Army for Financial Management and Comptroller, and Deputy Assistant Secretary for Health Budgets and Financial Policy in the Department of Defense. In this position, he was responsible for financial management, policy development, and program evaluation for the Defense Health Program. Prior to his government service, Mr. Ford held senior management positions in academic medicine and medical manufacturing, products, and health insurance. He was president and CEO of Clinipad, a manufacturer of disposable medical products. He also has served as Chief Operating Officer of Georgetown University Medical Center, with responsibility for Georgetown Hospital and financial oversight of faculty, practice plans, research activities, and the medical and nursing schools. Mr. Ford will speak about harnessing imagination, the ultimate disruptive technology.
Good morning. Thank you for that kind introduction. I'm pleased to be the keynote speaker for the 26th Annual Army Science Conference, and I'm honored to be part of a tradition that has existed since 1957. I'm sorry I'm not there with you this morning. When I got here to the Pentagon this morning, they told me the winds aloft were so turbulent that they couldn't guarantee I would get down there. And when an Army pilot won't fly, you're best to listen to him. As I said, since 1957, the Army has sponsored this conference to recognize and encourage the kinds of scientific progress that makes our nation a world leader in science and technology. Over the next few days, you will see and hear about the state of the art in many current research endeavors. You will discuss advances in many disparate fields of research: autonomous systems, biotechnology, immersive technology, nanoscience, network science, neuroscience, and quantum information science. The non-scientists among you will be impressed by the state of progress in all of these areas, and the scientists will be looking for the connection between your fields of research and other areas you are less familiar with. There will be fascinating hands-on displays and poster sessions, as well as lively panel discussions. It should be an incredible week. Among the advances displayed here are disruptive technologies, radical new developments that have the potential to supplant existing tools or techniques, or to create new paradigms altogether. As this research matures, the Army will harness this knowledge to give our soldiers new advantages on today's battlefields and those of the future. We are committed to supporting these endeavors. This conference is one of many initiatives we use to keep our Army strong. For a non-scientist, many of these discoveries are hard to comprehend. Some seem, at first glance, almost magical. But as unlikely as many of them seem, the key element underlying their development is, I think, surprisingly simple. These discoveries in so many disparate areas share a common thread and rely on the ultimate disruptive technology common to all endeavors: imagination. Now, I know that Thomas Edison said invention is 99% perspiration and 1% inspiration, and as the son of a scientist who spent many nights and weekends in the lab, I believe that. But without the inspiration rooted in the scientist's imagination, all the lab work in the world will generate little progress. Imagination enables us to conceive of the new, and then tangentially apply other technologies to make these newer creations both possible and plausible. The ability to imagine is a fundamental part of our humanity. It is an integral aspect of our minds. With it, we have the ability to capitalize on serendipity and clarify ambiguity. Imagination is an activity we do naturally, with little training or prompting. Imagination drives us. It compels us to draw connections, to seek patterns, to order chaos, or to connect disparate ideas. When properly harnessed, imagination can create effects far grander than we can foresee. The discoveries, research, and technology you see here symbolize this drive, its power, and its mastery. This is what I want to talk to you about today. Historically, militaries have invested in ways to put more kinetic energy on target, on demand. Soldiers looked for ways to increase the lethality of their weapons and to put as much distance as possible between themselves and the enemy. When contact couldn't be avoided, soldiers looked for good protection and the ability to sustain the force in combat. They looked for ways to communicate over increasing distances and to organize larger numbers of soldiers, and eventually combat took to sea and air. Armies became larger and heavier, and their weapons became more lethal until finally we developed weapons that put the very existence of mankind at risk. And while we have stepped back from that brink, it is not certain that humans will be able to avoid their own self-annihilation. However, in the past 60 years, we have ushered in a new era of warfare. We've come to understand the limitations of our traditional weapons on the modern battlefield. War is increasingly fought in urban areas, not on open plains. We are often fighting small numbers of zealots for the hearts and minds of the local populations, and our enemies don't follow the old rules. Our enemies intimidate and terrorize local populations while we try to avoid civilian casualties. Nevertheless, they are often successful in making us seem to be the aggressor. They use hidden bombs, secreted under roads, in cars, or strapped to their bodies, to kill and injure as many as possible in the most public way possible. How do we respond? How can we respond? This is the challenge we face today, and it is unlikely that future battlefields will feature much of the conventional combat action that we are so familiar with. We have established that our capability to defeat massed, uniformed formations is dominant. No one has much taste for taking on our combat formations. No, the future is likely to be more asymmetric, with enemies looking for seams and cracks and other weaknesses in our defenses. So as we search for competitive advantage on the battlefield, increasingly we look to basic research to create new capabilities. Recently, soldiers' and researchers' imagination have fueled many advances. Among many efforts where imagination has played a key role in advancing our capabilities are the electronic jamming technologies of our crew system and the latest prosthetic technology. In 2004, soldiers in Iraq faced a serious problem, the Improvised Explosive Device, or IED. At that time, we were unprepared for such a weapon, and we had no effective countermeasures. The use of IEDs spread quickly, morphed into new forms like the vehicle-borne IED and the explosively formed penetrator, EFP. And soon they were causing a majority of our casualties. As we developed tactics and techniques to counter these devices, Iraqi insurgents began adapting theirs. For instance, by moving from wire-controlled devices to cordless phones and remote-controlled toy controllers to detonate their IEDs. Organizationally, we were at a loss as to how to deal with this development, but soldiers' imagination brought us a solution. They began using the same RC toy controllers as an improvised jamming device. Activating all the buttons on the controller, they would attach the devices to their vehicles, giving them about a 100-yard jamming radius. Since all the controllers operated on similar frequencies, soldiers used the controllers to pre-detonate IEDs in their paths, turning an otherwise successful ambush into a spoiled attack. This imaginative application of a toy led to the development of the Counter-Radio Controlled Improvised Explosive Device Electronic Warfare System, or CREW. Leave it to the Army to come up with long acronyms. It changed the face and character of the battlefield, quickly altering the pace of military innovation and technology. Another advance came from the unique and pressing needs of injured soldiers, specifically amputees. It came in the form of the prosthetic technology known as the Luke arm, named after Luke Skywalker's prosthetic hand in Star Wars. To spur the advancement of prosthetics, DARPA contracted with the DECA Research Corporation to help create a new prosthetic limb. Dean Kamen, inventor of the Segway scooter, led the effort. He and his team imagined the creation of a modularized, fully articulating arm, which would replicate to the greatest extent possible a human one. Armed with their imagination and decades of electromechanical innovation experience, Dean Kamen and his team went to work. The results have been spectacular. The prototype arm is built in segments and is capable of fine and gross motor control. Relying on the amputee's existing nerves for control, the device has 18 degrees of movement compared to 22 degrees of movement in the normal arm, a drastic improvement over earlier prosthetic devices, and it is now ready for clinical trials. In just a few years of focused development, using the state-of-the-art in battery, material, and electronic technology, Mr. Kamen revolutionized prosthetic arm technology. His team did it through hard work, tangential application of existing technologies, and most importantly, imagination. We have seen similar improvements in vehicle armor in the frag kits and in the MRAPs, and with the ESAPI body armor. Robots, integrated ISR technologies, and autonomous surveillance and tracking devices provide better situational awareness, and our munitions are much more accurate and have greater range. But much more remains to be done. To reduce fuel consumption, the heaviest and most difficult supply items for sustaining the force, we need better batteries and more efficient vehicles. To get inside the enemy's decision loop, we need better intelligence, both human and signal. We need lighter armor and better blast protection. Imaginative scientific research and engineering enables seemingly pedestrian technologies to become disruptive ones. Through imagination, the impossible becomes possible. With it, new discoveries fuse with existing knowledge to build new tools and more precise applications. Imagination is the bridge to an amazing future. Many of you may have heard me predict that we are likely to see the Army's budget shrink in the near future. This is not pessimism born of the current economic crisis, but rather an observation of congressional behavior over the last 230 years. Further, there has been much criticism of DoD's weapons procurement process. The Army, despite the fact that we have relatively few large procurement programs, FCS is the only Army program in DoD's top 10, has not been immune to those criticisms. So while our procurement programs may come under attack in the coming months and years, we must sustain our commitment to basic research and to continue to provide the funding and support for our science and technology programs. The Army as an institution is committed to help the science and technology communities harness the disruptive effects of imagination. We recognize the inherent power and value of your work and its potential benefits for our soldiers and formations. Now and in the future, the Army's investments will push the state-of-the-art in many fields through basic research and applied engineering. And we will support venues for the display of our progress. Your imagination will be crucial to the development of these disruptive technologies that will give our soldiers and our allies significant advantages in battle. The imagination of American scientists has been essential to keeping our economy strong and the nation secure. They will be equally important in keeping the Army strong, both now and in the future. Thanks very much for your attention. Again, I apologize for not being able to be with you there with you this morning, and good luck in the rest of your conference. Thanks very much.